Hey, welcome to Physics in 5. For our first lesson today, we want to talk to you about measurement and about units and significant figures, accuracy and precision. So, Mr. Dupree, how tall are you?
Let me think. I think my height is 1.7.
Huh. Okay, well, I think I'm 5'2". So, who's bigger?
Well, you are. I mean, 5'2" is bigger than 1.7, right?
True.
You're taller than me.
Then I'm bigger, which you can clearly see.
Okay, that was sarcastic. The whole point of this is that we're trying to emphasize that units are important. She's 5'2", but what units did you use?
I use feet and inches.
I'm 1.7, but I used meters. And those are completely different units. And if you don't tack on the unit there, if you just say, oh, I'm 1.7, it's completely meaningless. So we have to be very precise when we use measurements. And that's what we're talking about right here. So in science class, we're going to use the metric system. We use the metric system for many reasons, so none of that feet, inches stuff. We're going to use meters to measure distances. And so one of the reasons why we use the metric system is because it is the most widely accepted unit of measurement around the world. So all the countries you see here highlighted in red are the 3 countries on Earth that refuse to use the metric system. So to be more universally accepted, we're going to go with the metric system.
This allows us to convert from one unit to another a lot easier so that we can be on the same page. It's possible that Mr. Dupree's height and my height can both be given within the same language. So to convert from one unit to another, we want to use a process called dimensional analysis. And this would just allow us to change one unit to another using a conversion factor. Just like if you buy a dozen eggs, you would expect to have 12 eggs. So it just is changing by a factor of 1, but the units will be slightly different.
All right, so to put this into perspective, we're going to go ahead and take a measurement of an actual object here. So we're going to choose something a little bit smaller than either of us. Now when we do this, we're thinking about in terms of precision and accuracy. So if I use this meter stick here, you can see that it's 1 meter long, but the rocket only goes to here. So how long is that? Well, it's less than a meter, but I don't have any better utensil right now, so I could just say, oh, maybe it's about half a meter. But if I use a more precise instrument to measure it, then you can see that I can be a little bit more accurate here with the decimeter setting. And then obviously I can go over to centimeters or even millimeters. But that's what it comes down to, precision versus accuracy. Precision is how precise the instrument is in measuring it, and accuracy is taking that measurement and seeing how it corresponds to the actual value. Sometimes we know the actual value, most of the time we do not. So it's very difficult to be accurate. But precision really just comes down to whatever instrument you're using to measure that quantity.
So we're always going to want to be as precise as possible. So I want to use the very best tools that we have to be able to measure things. Precision and measurement, like he said, only comes about when I have a tool that has some marks on it. So, is there anything that changes the length of this rocket? Like, does my height change it? Does measuring it on Earth change it?
Well, I mean, not really. I feel like if I measured it this way versus this way, I'm going to get the same reading, right?
Yeah.
So this brings us to a conversation about systems versus environment. In our little experiment here, all we did was measure this rocket. So in that case, this object would be the system. This is the thing that we care about. We took measurements about this. But in our little experiment, if you will, we were just finishing up with this, but nothing else. So this would be our system. Everything else is the environment. The meter stick is the environment. I am the environment. Ms. Jenkins is in the environment. The air, the projector over here, all of that is in the environment. Only this part is the system of our experiment.